Howdy everybody in YouTube land. What we have in front of us today is a weatherstar 3000. Now, I recently did a video on one of these, which hell, that's probably 2 years ago now, but I did a video on one of these that I restored and got it, with caps and all that stuff. That's a different unit, but this one was handed off to me by a friend of mine, and this one has got a strange fault. I don't know what it is yet. I haven't dove into it. Also, there's no schematic available for that, so it's going to be, best guess scenario to find out what's going on with it. But what I do know is it won't gen lock properly. It just completely freaks out like it's missing timing information from the gen lock stage. If you don't put a reference video signal in here, it's fine. But the minute you do, it loses its mind. The good news is the board in question is here on the top. So that's responsible for video generation and all of that stuff. So it'll be easier to probe with the oscilloscope and find out exactly what's going on here. But yeah, these things are insanely rare. I don't even own one myself. The one that I had was on loan. This was a deal worked out. I don't know, don't care. But what I do care about is it does not work, and we have to fix it. And guess what? It makes for good content, right? Because, you don't find these at all anymore. So, all right, let's take this lid off. Let's dive in and get something hooked up and figure out what we got going on. So I just got the lid off and popped this board loose. So first things first, all the capacitors are original. Probably not the issue, but it will need attention soon. But that's on him when he decides he wants to do that. But for now, I doubt that's my issue. Although I will scope the outputs, the voltage rails, and make sure they're clean. Because if the voltage rails are not clean, well, we're going to have problems. But more importantly, now that I got the board actually loose here, first thing I noticed right away is we have a DuPont wire that's just kind of like tacked on here. Probably for monitoring the signal coming off of these oscillators. And it looks like there's some chips that have been taken out and reinstalled, probably during troubleshooting prior to me obtaining the equipment. So that's all we know at this time. Now, one thing I've noticed quite right away actually is we've got some heat scorching around this resistor here. At least I think that's a resistor. Yes. She's been hot. So this thing's been on for a very, very long time, which I'm not surprised because this thing was sitting in a head end for I don't know how many years. Let's see, based on the date codes we have 1986 18th week, so this thing's about as old as I am. 87, so no, this is newer. 87, so this thing was probably put out in 87. Man, that would have been late for one of these because the Star 4 came out in, what was it, 88 or 89? Something like that. But anyway, so all the caps are original. I suppose at this point I'm going to get this wire off, resolder that because all the solder's been removed. So I want to put all that back in there. And we're going to go ahead and get the signal source hooked up. Well, I'm not going to hook up a signal source yet, but I want to get it all hooked up. I want to see what happens so we know where the fault lies. Because I think I remember in communication in passing that everything works until you go to put a signal in, and that's when the whole thing freaks out. So we're missing a gen lock signal. One of these ICs is bad, and we're going to have to find out which one it is. However, that's a custom, and the newer, I think there was another version of the 3000, a newer version. They replaced this with a little interposer board that has a IC on it and some passive components. Because I guarantee this is custom and they quit running those chips. I'm hoping that's not bad because I don't have the other 3000 anymore to look as a reference to make a new board to replace that, is what I'm saying. So I don't have the other one to clone. But anyways, so I think at this point we should just get it all hooked up. So I went ahead and removed this wire, and then I soldered this chip back down, but I'm taking a closer look. There's a lot of broken solder joints, like here and here, there, over in here. I mean, yeah, it's a dual layer board, but this thing has been on 24/7 for, well, since I've been alive, practically. So, I mean, legally they were retired in 2004, so it hasn't seen power, well, hasn't seen active use since 2004. But, yeah, I'm wondering if that is all it is. So, could I inadvertently fix it by just resoldering these chips? No, not all of them are that way, but some of them are. Like, that one's really bad. There's some bad ones in there. Okay, I'm not going to touch it. I just want to plug it in and see what happens first. Then maybe flex on this board a bit and see if it clears up. Or, well, hell, first we got to find out what the symptom is, because I don't even know. I'm just going based off what I was told. So let's get it hooked up and see what we got going on. In unrelated news, I found this little blurb sitting down in there. System ID 2100, Scott City. I don't know. Serial 7923-03. Is that what it is? Yes, it is. Huh. That's kind of cool. I'll have to put that back in there so we don't lose it. Yeah. I think this machine came from Henry, but I don't remember exactly. I think so, though. But, alright. Let's get it hooked up. One thing I'm noticing, because I'm getting all the cables plugged in, is this one's very loose. Yeah, that might be an issue. I'm not saying that that's the issue, but that would be kind of silly if it was. Yeah, I've seen dumber. Alright, let's see what we got here. Let's kick my monitor on. And then I have this because that's going to be my video input generator, but I don't have it plugged in yet. Because I just want to see what this thing does verbatim. So. Oh, come on. There we go. Alright. Let's see what happens here. We don't have any vertical sync. We kind of do, actually. And ignore that. The caps are bad in this monitor. Whoa! Did you hear that? Lightning just went BAM! Maybe I should turn this stuff off, actually. Alright. Because it's not like this is replaceable or anything. Alright. Alright, so this is just remnants left over in RAM. Okay, so the machine works. So now I just need to kick on my Blackburst, or just NTSC generator, and see what we got going on here. Let's see. I'm really asking for it because I'm working on this in a lightning storm. Yeah, that's Anyways, all right. Oh yeah, that's not good. No. You see that? We're missing a vertical sync pulse. Although it looks steady in the camera, but it's not. Turn that off. That's not good. So that's what it is. We're missing vertical sync. Horizontal sync is perfect because we're not losing anything this way. We're losing it this way. So the vertical sync pulse is being lost somewhere in this board. Huh. There's no schematic available. So where do we start? Welp. That is a damn good question. Okay. Well, actually, I'll tell you where we start. Remember how I said this thing looks like it had bad solder joints? Let's push on the board. See if we have any. I'm noticing that right away. Not that one. Let's reset this thing. RAM's got a bunch of crap in it. So, pushing on the board's not really... I mean, it is changing the behavior a tiny bit. But not like you would think. I mean, it's not supposed to do that. Yeah, there's bad connections in this board. For sure. But I think that issue might be secondary. Oh yeah. Definitely going to need to do some solder work. Okay. So where do we start? First thing to do is the patent. Actually, there's a patent available on this, and I think that's the wrong number, but there is a patent available on this that goes into somewhat detail on how all this stuff works. We could take a look at that patent, and that patent will kind of clue us in where we might need to look. So if I do that, I should be able to use a process of, elimination to say, okay, well, where can I start probing the oscilloscope and figure out where there's a missing signal? So, I wish I had a camera mount where I can just do a bird's eye view and do the whole troubleshooting thing, but I do not. So there's going to be gaps in the video when we figure this out. Alright, so here is where I'm at. I've been chasing my tail around for the last 2 hours. Now, there is a patent available for this particular weatherstar, like I said earlier. So there's the schematic that's in the patent. Now, this schematic is wrong. It's not accurate at all. I've already found a handful of differences. Plus, the pin numbering is not the same versus how it's drawn on the board, which makes sense because this is like version 3 of the same unit. So this is from the original release, perhaps even before it was even released, and this is a third version in. So it makes sense. But anyways, it's close enough to where I can kind of figure out what's going on here. So I'm chasing this circuit, and it's kind of complicated. It's very hard to follow. But what I found right away is this is the chip here for the gin locking circuitry that drives the vertical and horizontal output, right? So let's start there. Let's check the horizontal and vertical drive signal, which is right here. So we have horizontal drive 7, vertical drive 2. So now if we check vertical drive 2, which is this pin right here, that is not 60 hertz. That is trying to gin lock at 15 hertz. So what's the other one? The other one is 7. 1, 2, 3, 4, 5, 6, 7. Yeah, it's not perfect, but it's there. So anyways, moral of the story is I'm chasing my tail around here, going in circles and circles. And the problem is this sync pin is trying to lock in at 15 hertz versus 59.97. So it's a quarter of what it should be. So that already is a problem. Now, the 60 hertz has to come from somewhere. So I'm chasing around. This counter circuit here appears to be working, because if I go, let's see, pin 12 on the 191, which is here, yeah, it's literally at 15 hertz, so the counter is resetting like it's supposed to. Let's see, pin 4 is an input, which is here. And it's hard to tell because it's so narrow, but look, that's my 59.97. But if we chase that, it goes up to this 123 over here, but it also goes to pin 9 of this 123 up here. Well, that circuit works out to be there, and how I found it was judging by the time constant, 51 PF 22K. So if I check that input, which goes to pin 9, I have the same signal, 59.97, which is the A trigger input on the 123. Now this is a monostable multivibrator, so it's only stable in one state, and that is the asserted state, and the duration of that state is determined by the time constant, right? So that monostable multivibrator is being triggered according to that input, right? So that is the A input, and it's being triggered. But if I look at the output, which is right here, nothing. So that monostable multivibrator is not asserted. It is in the astable state. So why? Why is that not being triggered? Well, it is being triggered. We saw that. Everything else is in the true state. So this thing should have an asserted output pulse. It's on the Q output. So this should have an asserted pulse of the duration set by this time constant. So therefore, this is not doing its job. There's a problem here. And if we follow that, that goes to this AND gate 08. So this, since this signal was low, as we saw, that will never ever be true, which means this will never ever be true. There's no output going back into here, which goes into this gate. And if we follow it, it goes right back into the sink. So this circuit is doing absolutely nothing, because this can never go true because this isn't working. So if I disable the signal here for a second, like I said, it'll time itself, no problem. So if I take the input to this here, it's still there. There's still a signal there. And if I take the output, nothing. So that circuit is not working. This 74LS123 is bad. Or the resistor and capacitor is open or something. I have to check it. But I could be chasing a red herring. But I know for a fact that that circuit is not operating. It's not in a valid truth state for what it's designed to be. So that's a problem. I don't even have to calculate out what that's supposed to be to know that that chip is not working. So that's got to go. That's got to be replaced. So that's problem number one. We can't begin to troubleshoot the rest of it until that chip gets replaced. So there we go. That's where we are right now. So yeah, it's literally trying to sync at 15 hertz. It can't. It can't do that. Oh yeah, if you need more proof that this schematic is wrong, take a look at this. This is an output, the 74LSOO. Follow it, it goes to the output of a 7474. You cannot tie two outputs together unless one of these tri-states, and since neither one of them do, yeah, so I already know it's wrong. Alright, before I chased down a red herring, I went ahead and tested this. I pulled this 123 completely out, and I tested it in my 866 programmer, and it comes back as normal. So the chip, according to the programmer, is fine. So I went ahead and I pulled this capacitor out, and I tested it as well, and it's also fine. So I'm kind of, even though the response, man, this thing's noisy. The response is probably, maybe my scope isn't fast enough. Who knows? It's hard to say. So back in that chip goes, and we continue on moving forward. That's why I wanted to pull it and test it before I started ordering parts, because I don't want to be like, aha, that's it. No, it's not it. There's another problem, and it's just being masqueraded. Now, I did try to run this without the chip in there, and it will run, but there's no input video signal detected. So that chip is doing something. So Alright, so I removed this 123, which seems to be the video detection circuit for both the local video and the satellite video input. Now, to no surprise, it's good, but if we look at here, we have the local video present flag, which is done by this section of the chip, and then the satellite video present tag is done by this section of the chip. So, now that I removed this chip here, it's stuck solidly on. It's not flickering like crazy. So if I plug in my satellite feed over there, boom, I have video. Like if I reset this, it'll probably come up and show, well, maybe not. Yeah, see? It's going to show, and then it'll eventually disappear and show the background. Yeah, it's working normally. It's working. It's actually working properly now. So there's something up with that. So here's what we're going to do next. I'm going to monitor the input for the composite video input. See, there's composite sync, pin 9. So if I look at pin 9, which is there, I get that. And it kind of looks like a sync signal. I don't really see any problems with that. Alright, so let's take a look at the local video input, which is not a sync signal. So it should contain sync and video information as well. So we move over to local input here. And then we go and put it into, what pin is it? Pin 2. 1, 2. That looks different. But this also has video information. So that might be normal. I don't know. But there's a difference there. That's probably why this one has a 15 microfarad capacitor and the other one has a 2.2 microfarad capacitor. So I tested this cap and I tested that resistor and it's good. I also tested the 123. It passed. So I don't know. I don't know. I took this 191 out in case this was affecting things. So here, I took it out and it was still doing the flicker, flicker, flicker. So there's an issue here. And I don't know what or why. So this is floating right now. So this is input's going to be high, which is what we need, I think. And that's why it's showing that it's high. So if I plug this video in, because well, without it, it won't know that the video is unplugged. It's just stuck. So turn it off. Yeah, it's kind of there. It's kind of not. Yeah, it knows. So reset. See if it clears off. This will probably go away. Yeah, it clears off. So that's strange. But I bet as soon as I put the wrong chip in the wrong spot, I put this in here, it's going to do strange things. Yeah, I don't know if I can actually get it to fit in there. I should, you know what I need is I need sockets. Because I would just put a socket here and just be done with it. Interesting. Yeah, see what I mean? It's just flickering like crazy. So either there's a problem in that circuit, which I doubt it because I can't find one, or there's a problem with the composite sync. Now the problem is, this is the composite sync circuit here, which is coming off, let's see. Well, sat video. Yeah, so there's the sat video in, which is the exact same amplifier, so I can look at that right there. I can actually look at it right here. And this is just teletext video, so if I look at it right here, it should look the same. So pin 4 of the 710 sync separator. Yep, it's fine. So it looks the same as the local input did. So I know all of that stuff's working. The video amp, the CA3096, all that's fine, just like the other one. So I can rule all that out. Oh, this is complicated. Alright, so I've been studying this circuit some more because it's kind of confusing how this works, but it's really old school. So I've been studying this circuit. I pulled the data sheet to this guy, and I've just been kind of like studying the patent and all that stuff. So anyways, so this circuit, this chip here has a data sheet available for it, okay? Now, the data sheet says that the clock signal has to be phase locked with the incoming video signal, and this sync signal has to be phase locked with that too. This is the composite sync, so it needs both. It needs the 14 megahertz pixel clock as well as the, the composite sync input. Why it needs both, I don't know, but it does. So this circuit is all responsible for all of that crap. Now this potentiometer here will adjust the phasing between the clock and the sync, okay? But not only that, also over here, there's this circuit there. So now we have a color burst signal that will lock this. This is literally a phase lock loop, okay? So they're using a 3.579545 blah, 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 blah phase lock loop for the color burst. Okay, that makes sense. But what they did here was they used the ×4 analog multiplier that is not a phase lock loop. This is not a PLL. This is just a free running X4 with a tuning coil here, which is this guy right here. So the problem with that circuit is if it's slightly out of tune, it'll be running at slightly the wrong frequency. I don't know yet. I got to hook a scope to it and see. But this could be running at slightly the wrong frequency. So these things are no longer in phase with each other, no longer in sync with each other. And that'll cause a problem here too, because that means when this video presence signal comes active, it'll switch the clock supply over to here, to this gen lock signal, which this is the 14.31818 signal. It's the same as this one up here. But this is now phase locked with the internal color burst, or the incoming color burst. So, but then because remember, this chip provides outputs that loop all the way around. All of this circuit's tied in for some reason or another. It's all tied in. But if it's slightly out of phase, I can see these shift registers and the counter that's down here getting constantly reset because it's slightly out of phase, and it's causing the thing to just like on a beat frequency. Because one thing I can do is I can take this this 2.2 microfarad cap here in this circuit and jump that out with like this 47 microfarad over here. It'll slow down the amount of times it resets. Instead of going pop, 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 it'll just go 1, 1, 1. It slows down to almost once a second when it resets. So, but the point is, this circuit keeps resetting. It keeps resetting, which is causing this video presence signal to pulse, which is switching this, throwing the whole thing out of whack. So, none of these logic chips are bad. I went through it. Everything's fine there. All these little capacitors are good. There's no open resistors. So, the only thing I can suspect it being is the gen lock section is slightly out of tune. Okay? And that's just a big fat assumption at this point. So now there's two tuning points. There's the X4 multiplier here, which is not a PLL. It should be a PLL, but it's not. So that could be a problem. And then over here is the 5K pot, which is right there for adjusting the phasing between the composite sync and the video clock. So I would prefer to start here first, but before I do, I'm going to set up the scope and see if I get a free running oscillator signal coming out of that. I don't have a schematic, so what I'm going to do is I'm just going to probe this guy. Well, there's a 3.5 signal, but I got to turn it up and see if I got a 14 megahertz oscillator, because there's the transistor there, which is off the screen. Yeah, that's the transistor. Alright, so I gotta put the camera down to adjust the scope. But yeah, I swear I think this is it just being slightly out of phase. Alright, so I'm probed here at the coil, which is, well, I can't move the screen. And I got my cursor set at the peaks of the sine wave here. It's probably not the same sine wave. So I'm going to have to double check that, but I'm only getting 10 megahertz. So, anyways, I got to make sure that's the right sine wave, because it may not be. But that's already a problem. Alright, so I'm probing at a different point, and it's kind of hard to see what's going on here. But you can kind of tell. It's close. 15 point. It's very close. And one thing I noticed right away is it locked as soon as I'm touching that. So there is something wrong in that oscillator stage. See, now it's locked. Let's see if it locks in this way. Yeah. I'm gonna ignore that. This thing's got bad caps. As usual. What doesn't have bad caps anymore that's old? Not much. Anyways. Yeah, now it's locked. As soon as I started fiddling around in that circuit. So, I'm thinking our problem is this is out of tune. It has to be out of tune. So let's keep stabbing away at it. Alright, so ignore this. This is just garbage left over in RAM. So one thing I've done, when I did the previous video clip, I tried adjusting this, and it wouldn't correct. Shut the power off, back on, all that stuff, and it was flickering again. So what I did was I started testing everything, and this transistor was giving me some weird readings. So then I'm thinking, okay, well, let me grab the soldering iron. You can kind of see that little mark where I melted the capacitor. I heated this capacitor up with the soldering iron, and as soon as I did, problem solved. It corrected itself. It just went black and came back. I wish I got it on camera, but I didn't. Now, which capacitor is that? This one right here. This 0.01 that sits between these two transistors is right here. So there's something up with that circuit. And now it's working fine. I can cut the power off, turn it back on, and it's fine. So it'll lock itself here in a second. These 3000s are like that. Yeah, see, CPU kicked on. Boom. So that cap is bad. Pretty sure. So, and that's it's a funky capacitor too. I've never seen anyone like that. So that's got leakage in it. It has to. That's the only thing that makes sense here. Because now it's working. As soon as I got this hot with the soldering iron, it started working. Alright, now that it's actually working, I'm going to check the output waveform again. Yeah, it's still kind of bonkers, but that's a lot cleaner than what I had before. So there's definitely a fault in that circuit, or at least was. So let's go back here to the 7400, and yeah, that is not what I had before, but that's what I had now, and it actually looks normal. Although I see 4 frequencies, but that makes sense because it's a ×4 multiplier. It just doesn't have a filter. And that's the output from the AND gate here. So yeah. Yep, that's it. Faults in that circuit. Oh yeah, one more thing I wanted to address because I forgot to. These things here, these multipliers work off the principle of harmonics. So that's why when you scope these, like I'm going to scope right here at this point where the 220 is. That 220 is right here. That's why it looks like it's got 4 different frequencies there, or in phases. It's because these circuits work on the principle of harmonics. So it's doing a fairly good job filtering it out, or it wouldn't gen lock. But because of how messy it was before versus now, it makes sense because of how that looks. So before I was measuring right on the cap. So let's measure on the cap again. Yeah, that looks a lot closer in phase and together compared to the way it was before. So yeah, and when I touch that cap, this light blinks. So there, that cap is bad for sure. So they're starting to go leaky, I guess. It's the only explanation I have. These little plastic film caps, I've never seen them in any other circuits before. This is the first device I've seen those caps in. So they must be going leaky. So I think we're down to the bottom of it. So I'm going to try to see if I have another one of those on hand. I'll probably replace it with a green cap, those little green Mylar film. It's probably what that was originally. Like these. I think those are Mylar film. I'll probably just throw another one of those in there. And that should take care of the problem. Alright, so there we go. New capacitor soldered in. And it's just a standard Mylar film. Whoa, I don't want to drop it. It's a standard Mylar film. It's just kind of like chilling out right there now. So now what I've noticed is all of those black capacitors are all 10 nanofarad caps, or 103 as they're marked. Rest of them are not. So I don't know why they chose that particular one. I mean, we'll never know because the people that probably engineered this doesn't exist anymore. Alright. So, see what happens. Boom. Turn the monitor on. Seems to be working fine. So, at this point, bumps out of lock like it's supposed to. And see if it comes back in lock. Yeah, sure does. It doesn't like that because there's no color information. So yes, it's working as it's supposed to. Alright, so now let's get some data in this pig and see what happens. So yeah, to correct some earlier things I stated in the video, it wasn't the loss of vertical sync that I thought it was just by how it was acting. It was actually the loss of burst lock. So it was picking the signal up, but there was no way for it to there was no burst lock to maintain. It just wasn't there because the burst lock is multiplied by 4 through that circuit and it wasn't there anymore. So because when we switched this to black and white mode where there was no color burst at all, you see what it did. It did the exact same thing. So that's what it means for the 3000. When it does that, it's not able to maintain burst lock at all. So now, to correct my statements in the earlier video with that information, now it all makes sense at this point. Well, who knew 40 plus year old knowledge would be needed now? Oh man. Alright, well, we're back up and running again. Modulator's connected. I just got to get power to it now. And hopefully... I definitely did not make this easy. No, I did not. Now, did I? I made this for the VCF show, for showing off, but... yeah, I definitely didn't make it easy any other way. Alright, so there we go. Power. Hopefully it works. Yeah, it's going. I think. Oh, there it goes. Kinda. Alright, well, the problem is there's no, the addresses aren't set right. They got to be set to, specific address based on what it was. But I should still get a clock signal. Hopefully. So, stand by while I get all that set up right. Barely getting a twinkle. Alright, so I got the modulator hooked up. Everything's wired up as it's supposed to be. Video going in and out for the sync signal. Data is being present because, well, I don't want to show that on screen. Data's being present. All that stuff's good. I got a sub-carrier indicator, but no data activity at all. I even adjusted the switches. So, one problem solved, another problem to figure out. Now, I'm going to go ahead and try to roll out my setup. So I'm going to go grab a weatherstar Junior real quick and hook it up and make sure it works. Because then that will tell me if the problem is isolated specifically to this unit, which I think it is. Because this came out of my rack and I know that one works. So I'm thinking, that's what it is. I adjusted that to my settings too, so... Anyways, yeah, so I'm going to have to figure out exactly what's going on here. I think we've got a demod issue on this board. And I do have the schematic to this one because I reverse engineered it. Alright, so here we go. I got a Junior hooked up, so I don't even know if this one even works. This has been in my stash. Okay, it does. Video subcarrier should come up in a minute. It does. No data though. Huh. Oh, no. There it goes. We're good. Yep, it's fine. Okay. Let's see. Let me do a data blast here real quick. Sending update. There it goes. So we should start getting data in here any second. Okay, we're good. Alright, so the 3000 definitely has a fault in the data demod. So that's our problem. We got one problem fixed and another problem to solve. So yeah, where to begin? Alright, so I'm going to have to take these two boards off the top so I can probe this one by itself. Now, obviously, it's not going to receive data digitally with the rest of the boards out, but all of the entire analog section and the demodulating section should be exposed so I can look at it on a scope. And the good news is, I know what I'm looking for because I've already reverse engineered this stuff 3 years ago and already built the modulator, so I already know how all of this stuff works. So, and perhaps more importantly, I made my own schematic. So what we got here is we have the input from the FM quadrature section, which goes off and goes into the clock recovery stage, which is here. And then we have the data demod stage here. So, and then we have our 21-bit cipher block that they used for the encryption algorithm and all of this fun stuff. So if I'm receiving data properly, I should get a proper bit clock, which is 124.6 kilohertz. I'm pretty sure. And then we're going to have the data clock itself as well. Plus then we can verify the jumpers that they're all correct based on my notes that I put in this drawing. So I'm going to work my way back from the input stage and all the way through with the scope. And we're going to find out exactly what's going on. Alright, so here's where we are. I have my oscilloscope probe connected to pin 10 of U45. Why there? Well, I'll show you. So, the demod section, by the time the packet gets, the bit clock has been recovered, the clock recovery, the data bit demodulator, all that stuff, once it comes through and gets through all that, we have two signals here. The data drive and the bit clock. So we have data and clock. So think of SPI. That's essentially what we have here. We have data and clock. Now, within the teletext frame packet, we got 55, 55, 27, blah, 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 blah. 27 is the framing code. Well, this ROM contains the framing code, and each time that code is, seen by this chip on these lines, it's gonna enable the frame detect. That tells the computing system that we have a valid teletext frame awaiting. Okay, because we have an address. This ROM is removable, so you can change the framing code. That way, you can separate teletext frames from other frames on the same network. So we're going to turn the power on, and then pin 11 goes to that chip here. So, or pin 12. Anyways, there it is. See that? That is a valid teletext framing code detected. So this is going low, which is going into this preload register on U45 pin 10, which is where I have that oscilloscope probe. I need an extender so I can take this board and set it out, because I can't get in there to troubleshoot anything. And I think it looks like the S100 style connector too. But I need something so I can set this board out, because I've got no demod and I can't probe it, because those two boards have to be in there. So unfortunately, because I can't get a card edge extender, I'm probably gonna have to make one. I'm probably gonna have to make oh man, I really don't want to do that. I'd rather have ribbon cables. But I think I'm gonna have to make a circuit board to plug ribbon cables or something into, and I have to make two of them. I'm gonna have to make one that plugs into this. I'm gonna have to make another one to solder that into, and make an extension board. So I'm gonna have to figure that out. I don't have a solution right now for that. So I did have a chip that was bad on me, and I think I caused it. This one went bad, and I think because the scope ground is isolated, it's floating. The ground popped off on me when I was probing that chip, and it damaged it. So I changed that out. So that was my fault. I tried adjusting the core for the bandwidth, and it's not really changing the behavior at all. So there's another fault on that board somewhere, and I thought it was passing through, but it's not. I was getting the trigger of the framing code detected, but after this would warm up for a little bit, it would go away. So there's clearly a problem in the DMOD for sure. So I decided to get the logic analyzer hooked up. So I have the clock source, the trigger source is coming from the modulator, and I have the data demod connected in, as well as the data modulating source. All of that's done. Got this jumper moved over, which disables the cipher encoder. And so here's what we have on the screen. Now, if I set this up into looping mode, we can see the data changing as it's coming down from the server. But notice, this is what's going out of the wire. That's what's coming back. We're missing bandwidth. We're missing data bits. Now, if I take this tool here, and I twiddle on this coil, which is in the radio circuit, I can actually bring that back. See? It's barely giving it. So, oh, here we go. We're starting to get data back. But if I let go, it starts to drop off. So it won't stay tuned. So I think we have another bad capacitor in this circuit somewhere. The IF will not stay tuned. So we're losing bandwidth. It's not holding it. And just like that, it's fixed. Damn thing's out of tune. So now I don't have this radio section mapped out. I don't know which coils do what yet, so I'm just kind of shoving them in the holes and turning them. Now some of these are responsible for FM audio, which will never be used again, so it doesn't matter anymore. But so I was adjusting this one, and we saw what was happening on screen. So I moved to the next one. Now look at this. Besides a little bit of glitchiness here in the very beginning, that's it. We're locked on now. So that coil absolutely is important. So now I'm going to go back and twiddle this one again, because now it's in a different spot compared to where it was before. Oh, Yeah, you can kind of see it. There we go. Now this is normal. This is just the analyzer doing that. Because you can see it doing it here too. But yeah, so we might have this in the bag. We'll have to see. So right now I'm going to power it down. Alright. Shut you off. And then get the boards back in here and see what happens. Alright, so here we go. See what happens. Almost. Now I've noticed if I put this board in, it'll change the tuning a little bit. So why that is, I don't know. Probably because the CPU is getting into the tuner. But I get a little bit more blinky than I had before. But we're still not quite there yet, so I'm going to have to start tinkering with the tuning a little more. So I twiddled those coils just ever so slightly, and one thing I've noticed is that coil is super touchy. You bump it just a tiny bit and it loses the whole thing. And I got it close enough to where it's pulling in data now, but it's just slightly wrong. It's still a little bit corrupt, and this light is still inconsistent. It's supposed to be solid and not flickering like that. So, yeah, see what's going on here? It's kind of interesting. Yeah, so there's still a little bit of bit error. So the problem is tuning that IF stage to be exactly what it needs to be is not something that's going to be simple, because like I said in the last video, you can't get in there and twiddle it with it out. I mean, yeah, look at that. So you can't get in there and twiddle that with the board stacked like that. So I'm still trying to figure out how to approach that. So I need to, well, at least we know what the problem is. So I need to get in there and we need to tweak it just a little bit more. Just ever so close. It's that close. So after it's been off for a while and it's cooled all the way down, and I just turned it back on, look how stable it is, which is kind of hard to see because it's in sync with the refresh rate. But that light is lit up. Now, as far as data is concerned, it's perfect. No glitches in the text or anything. It's all good. So that tells me that the radio components drift with heat, which it's not supposed to do. They're supposed to be temperature stable, which kind of makes me think that there's a metal film capacitor or mylar cap, or one of those caps in the front end is drifting, which is causing it to detune itself as it gets warm. Not supposed to do it because it was detuned originally. So that kind of makes me think those IF cans have like silver mica disease or something. I don't know. It's weird. But it's working perfectly now that it's been off for the last hour and cooled all the way down, because it's perfectly in tune. There's no glitches. But yeah, works perfectly fine. But once this thing warms all the way up, it's going to garble the screen and we're going to have issues. So I don't know why that is just yet, but I'm sure I'll figure it out. I might have to recap the front end and retune it. See, it's perfect.